What about kinetic energy? Okay, number two is kinetic energy. Kinetic energy means the energy of motion. Motion, okay, the energy of motion. So when this body, okay, move from this place to another place, right here, okay, it moves a distance, yes, and it has a mass. Of course it has a mass, and it also have a velocity. What is the meaning of velocity? Velocity means speed. Okay, so this body has mass and velocity. Okay, mass, okay, we know mass is measured in gram. Velocity is speed. Speed is measured in meter per second or kilometer per hour. Okay, so when I want to make a law to measure the kinetic energy, I say that kinetic energy Ke equal half mass times v square. Okay, and here we have divided. So the kinetic energy equal half mass times v square. So kinetic energy depends on the mass of the body and the speed of the body. Okay, done the second law. The third law we have is mechanical energy. Mechanical energy, and mechanical energy is the most easiest one. Mechanical energy equals kinetic energy plus potential energy. Okay, so if the kinetic energy equal 20 and the potential energy equal 30, so the mechanical energy equal 20 plus 30 equal 50 joule, and energy is measured in joule. Okay, thank you. So we have heard some laws in this lesson. The first law we talk about the last session is the law of work, and we said that work equal, do you remember? Yeah, work equal force times displacement. Okay, and the second law we have right now in this lesson, we have potential energy. Yes, potential energy, and we said that potential energy depends on two things, weight and height. So depend on weight and height. Okay, the third one we have is the kinetic energy right here. So kinetic energy equal half mass, okay, times v square. So it depends on the mass of the body and the velocity or speed of the body. The third one we have is mechanical energy equal kinetic energy plus potential energy. The most easiest one. Okay, easy measy little squeezy. Let's have an example that illustrates and show us the difference between potential energy and kinetic energy and the mechanical energy. Okay, if we have a pendulum, you know the pendulum? Yeah, the pendulum is something with a wrapped to a rope, okay, like this. Of course you know. This is simple pendulum, okay. Simple pendulum, this ball move up and down. Okay, move up and down. Okay, we know this. So, in the highest height here, okay, the potential energy is maximum, and in the lowest height, the kinetic energy is maximum. Here in the maximum height, so potential energy is maximum. Yes, okay. So we have a relation here that potential energy in love. Yeah, in love with what? With height. When height increases, potential energy increases. When height decreases, potential energy decreases. So this relationship. Okay, while the kinetic energy hates hate the height. The kinetic energy hates the height. They hate each other, so the relationship between them is very awful. Okay, when kinetic energy increase, the height decrease, and the opposite. Okay, so if I tell you that potential energy is maximum at the maximum height, so here the potential the kinetic energy is minimum, yes, or equal zero, we can say that. Okay, and here the kinetic energy also equals zero, minimum. Here the potential energy, yes, minimum. Okay, so this is a simple pendulum and the exchange between the kinetic energy and the potential energy inside it. Okay, another example, if I throw the ball, you remember this ball, a ball from the ground up to the sky. Okay, then it go up and then go down. Okay, here I want to calculate the potential energy. Okay, write that. Okay, and the kinetic energy. Okay, in the lowest speed or the highest speed, if I say that the potential energy equal 100 joules, this is maximum energy, so the kinetic energy equal 0, yes. Okay, when I go down, the potential energy began to decrease and the kinetic energy began to increase until we reach barely the ground, so the kinetic energy here is 100 joule maximum and the potential energy at 0. Okay, the opposite one. What about the middle? In the middle, who is bigger than the other? In the middle, the potential energy is equals 50 joule and the kinetic energy also 50 joule, so they are the same. Okay, can you calculate the sum of both kinetic energy and the potential energy? Here the sum is 100, yes, 100 joule. 0 plus 100 equal 100, 50 plus 50 equal also 100 joule, yes. 100 plus 0 equal also 100 joule. So this 100 joule is called mechanical energy. Okay, and we know an important note, very important note, a very important note. This note say that mechanical energy, you know it, mechanical energy doesn't change. Doesn't change. Mechanical energy doesn't change at all. Can be changed. It's a constant. 100, 100, 100 is constant. Can't change at all. So this is the difference between kinetic energy, potential energy, and mechanical energy, and how they can alternate in the same ball, and how they can alternate in the simple pendulum. And here we have the 4 laws in this lesson. Work equal force times displacement, yes, and potential energy equal work times height, kinetic energy equal half mass times v square, and the mechanical energy equal kinetic energy plus potential energy. And goodbye, middle one, my beloved students.